Hi everybody, this video goes over the second part of section 2.1, and here we are going to talk about the applications. And in this particular one, the primary application is what we call profit loss analysis. And the question here is, in order to maximize profits, how much of an item should we sell? One thing which might make sense is that if we reduce the price, we will make more items. But the question is, if we do that, will we actually make a profit? Well, the way to figure that out is through something called a profit loss analysis. And there are four components to this analysis. The first one is the cost function. Okay, and the cost to produce X products will have a fixed cost, which will be the purchase or the rent of the building, the payment of the support staff, the maintenance of the equipment, and also your employee costs, and then the cost per product, which might primarily include the raw material to make the product, and perhaps even the actual labor to make the product, depending upon how the labor is organized. The next is called the price demand function, and this is pretty much how this works, and you can sort of see it here. Here we have X is the demand for a certain product, and here is the price for a certain product. And as you can see, the lower the price, the higher the demand. If the price goes up, the demand would go down, as one would expect. Well, if we turn this around so that price was on one side and demand was on the other, you would have the exact same thing. If you want to sell more of a product, you need to lower the price. If you can get away with selling less of the product, you need to raise the price. So for a given demand, if you want to sell X products, if you want to have a demand of X products, then you need to set the price. You need to set the price at P of X. Now, how is this computed? Or how is this determined? Well, essentially, market analysts will go over their historical data for the market price, and based upon the analysis, they will come up with a relationship. Sometimes that relationship will be linear, as you see here. Sometimes it is not. Okay, the third component is the revenue. Well, what is the revenue? It is the price of the product, and here it is, times the number of products you're going to sell. And that's what you have here. You have that the revenue is equal to the number of products you're going to sell plus the price of the products. So this basically assumes that your demand is X and that you are correct. And if that's the case, this is what you're going to get. You actually have X times P of X, which is a quadratic function. And then the profit, well, that is nothing more than the revenue minus the cost. Remember, the cost is equal to A plus BX, where this is the fixed cost, this is the cost per item, and this right here is the revenue. And when you're done, you have this. Now notice this is a quadratic equation. Also notice that our coefficient is a negative number. As a consequence, if you were going to graph this function, it will look something like this. It would be a parabola facing down. So this right here is your profit. This right, well, PR. This right here is X, and it will have a vertex, which is right here. Okay, and that vertex will occur when X is equal to M minus B over 2 times N. And we'll figure out where that comes from as we go through this particular chapter. But this is what it looks like. So at some particular point, if you sell enough, you're going to maximize your profit. If you sell too many, which means you really have to reduce the price, you are going to start losing money. And similarly, if you sell too few, you will also begin to lose money. This doesn't really make sense because you really can't sell negative products. Okay, now, and as we mentioned before, if your profit function is positive, that means your revenue exceeds your costs and you are making some money. If the profit is equal, that basically means you're breaking even and your revenue is equal to your cost. But still, that's not good from a business perspective, because we need to make money or your shareholders will get upset with you, and you'll be out of a job eventually. And then finally, if your profit is less than your revenue, or your profit is negative, well, that means your revenue is less than your costs and you are losing money, which is even worse than breaking even. So with that in mind, let's take a look at our first example. Here is here is the price demand function. So we have that a company is manufacturing notebook computers, and its marketing research department, using statistical techniques, collected the data in this table where P is the wholesale price per computer at which 1,000 computers can be sold. Using special analytical techniques, namely regression analysis, the analysis produced a price demand function, and here it is to model the data. Now notice that this function is valid whenever x is greater than or equal to 1 or less than or equal to 25. If x is equal to 0, this equation is not valid. If x is equal to 26, once again, this equation is not valid. That's going to be important. Okay? Because in part A, we want to plot the data points in the table and then sketch a graph of the price demand function in the same coordinate system. Of course, you don't have to do that. You just need to recognize the correct plot. Now remember, this is our model. It is valid only between 1 and 25. Now notice, this graph right here goes all the way to 0. Well, that's outside the model. This graph is wrong. Similarly, this graph goes all the way to 0. Okay, once again, that's outside the range of validity. So this graph is wrong as well. This graph also goes all the way to 0. So this graph has to be wrong. The only graph that is correct is this one right here. But let's go ahead and just make for sure that it's correct. Well, namely, it is graphed between 1 and 25, which is what we want. Or let's look at one additional point just to make sure that this is right on. For example, let's take a look at the case where x is equal to 10. If x is equal to 10, then p of x, or p of 10, is going to be 2,000 minus 40 times 10, which will be 2,000 minus 400, which will be 1,600. Okay, so when x is equal to 10, we are right here. Okay, when for 1,600 is right here. So if we come up and we actually hit this, we will hit this graph here. And then if we go on over, we are at 1,600. So this point does indeed work. So this has to be the correct thing. I want to talk about one more thing before we move on to another problem, and that is, in a number of cases, you might need to figure out what the range is for these divisions. Now, the way we can do that is, notice here we have from 960 to 1,200, 1,120, and we have 1, 2, 3, 4 divisions. So what you're going to want to do here to figure out the value between each of these divisions is subtract this, and if you did 1120 minus 960, you will actually get 160. Okay, so this distance right here is 160. There are 4 divisions, and 160 divided by 4 is 40. So each of these divisions is worth $40 or $40. Okay, and that might come in handy if you actually were at this point right here. That would of course be 1640. So that's just an idea of how you would compute the divisions for things which are kind of a little off. Okay, so this is the correct one, so we are good to go. The next problem is, what would the estimated price per computer for a demand of 18,000 computers? Well, we can compute this equation. Matter of fact, that would be the preferred way to do it. There is another way. Let's come back here. Here's our graph. This right here is 18,000 computers. It is right there. Okay, so let's go up. Let's take this graph and go on and take it up, and we see it intersects the line right there. Okay, and then that comes across to this value right here, which is 1,280. So the price for a demand of 1,800 computers should be $1,280. Well, let's make sure. P of 18,000, or P of 18, because this is in reference to thousands of computers, that is going to be 2,000 minus 40 times 18. Okay, that is going to give us 2,000 minus 720, and you guessed it, that's 1280. So it does work out. What about for 16,000 computers? Well, once again, we can do that graphically. Here is 1,600, or 16,000. Let's go up so we see the line. It actually hits right there. Let's go across, and it's that point right there. Okay, so notice that that is two divisions, and each division is 40. So 1280 plus 40, that gives me 1320 here. Plus another 40 gives me 1360. This actually is 1360. So that tells me that our answer should be 1360. Well, let's make sure. P of 16 is equal to 2,000 minus 40 times 16. That's going to be equal to 2,000 minus, I forgot the zero there, minus 40 times 16, or 2,000 minus 640, which will be equal to 1360. So it does indeed work out just fine. And that takes care of everything in the first problem. Let's go to the next one. Okay, here we are given a price demand function. Here it is. The question here is, what is the revenue function? Well, remember, the revenue function, R of x, is going to be equal to x times P of x, which of course is going to be x times the quantity 105 minus 4x, which will be 105x minus 4x squared. That right there is the revenue function. So this is A. For part B, what is the domain of the revenue function? Well, remember, the domain of the revenue function is basically the same as the domain of the price demand function. Well, this is A, sorry. So that will never change. So for B, the domain is going to be all values of x between 1 and 20. If they want it in interval notation, that would be the closed interval between 1 and 20. So we would actually have brackets because we have non-strict inequalities. And then finally, we need to complete the table. So here's our table, and we need to go ahead and complete it. And it might be good if we actually used our calculator to do that. So let me bring my calculator up. There it is. Okay, let me clear all this stuff. And now remember, the equation is 105 times x minus 4x squared. And our first value for x is going to be equal to 1. Now that would be very simply computed as 105 minus 4, but I'm going to go ahead and do it directly, and you'll see why in just a second. So to write that out, it's going to be 105 times x, which in this case is 1, minus 4 times 1x, which one is 1, squared, and there you go. Press equal, and you will get 101, which is exactly what you would get if you just did 105 minus 4. Okay, so there we go. We got that done. And you can write that in your table. For the next one, what we can do is just go up until this is highlighted, hit enter. Okay, once that is down, since the next x variable is 4, we can just, everywhere we have a 1, we'll just replace it with a 4. So I'm going to come back here, hit 4, and it just will overwrite that. Come back over here, hit 4, it overwrites that, hit enter. That's our answer for 4. Do the exact same thing for 8. Go up 2, hit enter, change the 4 squared to an 8, and this 4 to an 8. So make that an 8. We'll overwrite it, come over here, make that an 8, it overwrites, and we have 584. Okay, next we have 12. For that one's a little bit trickier. So we're going to go, but once again, we're going to go up. We're going to highlight this and hit enter. But now we had to replace this 1-digit number with a 2-digit number. And the way that I'm going to do that is I'm going to highlight the 8. I'm going to delete the 8 with the delete key. Then I'm going to hit insert. That will be second, insert, and now I can put in my 12. 1, 2. I'm going to come back to the other 8 and do the exact same thing. Delete, second, insert, 1, 2, and now I can hit enter, and I get 684. Okay, now I'm back to doing what I just did before. I just need to change the 12 to a 16. That basically is just changing that 2 to a 6. So I'm going to highlight this, hit enter, go to my first 2. That's not the exponent. Replace that with a 6. Go to the other 2 by the 105. Replace that with a 6. Hit enter. And notice that my revenue went down. Now, why did my revenue went down? Well, remember, as the number of items sold goes up, down goes the price. And now we've gotten to the point where the price is going down so much that our revenue is beginning to decrease. Okay, we have one more point, that is 20. So let's go ahead and do that. Once again, go up, hit enter, replace each 16 with a 20. 2, 0. 2, 0. And the revenue goes down even more to 500. So once you're done with all that, you can fill that stuff. You can fill that data into your table. Since we actually did that on the calculator, I'm not going to bother doing that here. But hopefully you did that on your guided notes, and then you will be done with example 11, which of course would be the second problem in your homework. Okay, the third problem in your homework is, well, obviously the profit function. So here we have the revenue function, which is 100x minus 4x squared. It's a different revenue function. It's valid between 1 and 20. We have the cost function where the fixed cost is 150, the variable cost is 16, and that's valid between 1 and 20. And I'm sorry I forgot to put that information on your guided notes. But now we need to compute the profit function. Well, the profit function is nothing more than the difference between the revenue function and the cost function. That is 100x minus 4x squared minus the quantity 150 plus 16x. And if you simplify that, and put that in standard form, you're going to have negative 4x squared plus 84x. That is your profit function. Okay, what is the domain of the profit function? This is the domain of the profit function. Since the domain of the revenue function is from 1 to 120, and the domain of the cost function is the same, the domain for the profit function is going to be all values of x between 1 and 120. No, not 20. Not 120, but 20. And of course, in interval notation, that will be the closed interval between 1 and 20. Okay, and then finally, to complete the table, we'll just basically use this equation. We can use it the exact same way we used it in the calculator before. However, I'm not going to do that since we kind of did that already. And if you did it for x is equal to 1, you are going to get a profit of negative 70. You're losing money. We don't like that. If you produce 4 units, you are going to make 122 bucks. All right. If you produced 8, you will make $266. If you produce 12, you are going to make $282. We like that. However, if you produce 16, you are only going to make $170. And if you are going to produce 20, you are once again going to lose money. How much can you produce to make a profit? Or what level of production would actually maximize your profit? Well, that would once again be equal to B, which is 84, divided by 2 times the negative this value, which will basically be 8. 84 divided by 8 is 10.5. So you obviously can't make 10.5 items, so either 9 items or 11 items will actually produce for you the same level of profit. So somewhere around there, so these two items, so these two numbers will give you the same value for profit, will give you the same amount of profit. So these two values, if you produce 9 items or 11 items, you will be maximizing your profits. Okay, the last part is to choose the best graph for the table. Now remember, our function is p of x is equal to negative 4x squared plus 84x minus 150. This is a parabola that is facing down. Okay. Whenever you have something other than linear, then your graph is going to have some sort of shape. It's not going to be a collection of straight lines. So this one is definitely out. These three are definitely out. Now, if you want to make sure that this is accurate, just remember when we produced 1, we got negative 70. There's negative 70. When we produced 20, we got negative 70. When we produced 16, what did we get? When we produced 16, we had 170. Well, there's 170 right there. When we produced 12, well, here's 12, we had 282. So as you can see, this fits perfectly. So this, of course, is the graph. And this brings me to my last problem. This one's kind of interesting. Actually, I meant weird. I actually really mean weird. And this one has to do with politics, and I can assure you it's contrived. It says here that the percentage S of seats in the House of Representatives won by Republicans and the percentage V of votes cast for Republicans when expressed as a decimal or as decimal fractions. That won't be highlighted in your homework, but I'm highlighting here so that you guys don't make the same mistake I did while going through the homework, are related by this crazy equation, which is valid for all values of S between 0 and 1, and then only for values of V between 0.175 and 0.8. Okay, now the first question here is express V as a function of S. Well, let's start off with this one, and what we would do is we would add 3S to both sides. And if we did, we will have 12V is equal to 3S plus 1.5. We can divide both sides by 12, or that should be a 5, not that. There we go. 12, and if we do, we will have that V is equal to 1/4 S, or the way I'm going to write it is 0.25 S plus, and this right here is basically 1/8 or 0.125. So that right there is our equation. Now for the next part, we have for the Republicans to win 52% of the seats, they would need to win what percentage of the votes? Okay, now remember S is the percentage of seats, but it has to be expressed as a decimal. So if this is 52%, then S has to be equal to 0.52. Okay, so we just put in 0.52 here and see what we get. That will be that V is equal to 0.25 times 0.52 plus 0.125. And that would give us 0.255. Okay, so that is our decimal. The percentage of the votes would be, they would need to have, to get the percentage, we'd want to multiply this by 100, and that means we will have that V is equal to 25, or the V is equal to that. V will be equal to that. They will need 25.5% of the votes. Okay, now for the next problem, or for the next part, we need to express S in terms of V. So let me get rid of that stuff. Let me get my let me get a red pen going. That red pen. Okay, so here what we're going to do is we are going to subtract 12V from both sides. So minus 12V, because remember we want to get S by itself. Minus 12V. These will cancel. We will have negative 3s is equal to negative 12v. That's supposed to be a 12, not a 72. 12, okay, v plus 1.5. Okay, now we're going to divide both sides by negative 3, so divide by negative 3 here, negative 3 here, and negative 3 here. These will cancel. We have s. S will be equal to, well, negative 12 divided by negative 3 is going to be positive 4 v, and then 1.5 divided by negative 3 is going to be negative 0.5. So it'll be 4v minus 0.5. And with that, we can answer part D. Here, if the Republicans win 18% of the vote, what percentage of seats will they win? Well, remember, if they're winning 18% of the vote, that means that V is going to be the decimal equivalent of that, which will be 0.18. Okay, so we have that. So then we're going to have S is equal to 4 times 0.18 minus 0.5. And that's going to be equal to, make sure that looks like a 5 there, 0.22. That is S. Well, if S is 0.22, that means that the percentage of seats that they will win will be that times 100, or let me do it over here, 22% of the seats. And that is all I have for this video. If you have any questions, please feel free to reach out to me. This is Bob Boyle, signing off.